Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study about the sp hybridization but with two pi bonds in the structure. For that thing, let's take an example of carbon dioxide molecule. So our example today is carbon dioxide molecule, that's CO2. Now let's make the firstly Lewis structure of CO2 molecule. That's the carbon, here's the first oxygen and here's the second oxygen. Now how many valence electron does carbon have? The atomic number of carbon is 6, so the valence electron will be 4. That's first, second, third and the fourth. Now let's talk about the oxygen. The atomic number for oxygen is 8, so the valence electron for oxygen will be 6. So it's 1, 2, 3, 4, 5, 6. And for second oxygen also it's 6, 1, 2, 3, 4, 5 and 6. Now carbon will make two covalent bonds with the first oxygen and the two covalent bonds with the second oxygen. Now let's count the valence electron of first oxygen after the formation of two covalent bonds with carbon. That's number 1, 2, 3, 4, 5, 6, 7 and 8. So the octet of oxygen is completed after forming two covalent bonds with carbon. Now let's talk about the valence electron of oxygen after the formation of covalent bond with carbon. I'm talking about the second oxygen. So that's the number 1, 2, 3, 4, 5, 6, 7 and the 8. So the octet of second oxygen also completed after forming two covalent bonds with carbon. Now let's count the valence electrons of carbon after formation of four covalent bonds with two different oxygen atoms. So that's number 1, number 2, number 3, number 4, number 5, number 6, number 7 and finally the number 8. So the octet of carbon is also completed after forming four covalent bonds with two oxygen atoms. So here carbon is forming double bond with the first oxygen and also the double bond with the second oxygen. In the previous lecture I have told you that whenever there is a formation of double bond between two atoms, then out of them one will be the sigma bond and another will be the pi bond. Same goes to the another oxygen also. The one bond will be sigma and the another bond will be pi. So before starting the hybridization, I want to tell you one point, and that is hybrid orbitals. Hybrid orbitals only forms sigma bonds but not the pi bonds. Now in case of CO2, carbon will be the central atom because carbon is forming maximum bonds, that's 4, and oxygen is forming 2 bonds. So carbon is forming 4 bonds, so here the central atom will be taken as carbon. Now let's talk about the carbon. What's the atomic number of carbon? It's 6. What's the valence electronic configuration of carbon? That will be 2s2, 2p2. Now let's make the orbital diagram in the form of boxes. The 2s subshell will have only one orbital, whereas 2p subshell will have 3 degenerate orbitals. The degenerate orbitals were those which were having equal energies. So the orbital of 2s will be called as 2s, and the 3 orbitals of p are named as 2px, 2py, and 2pz. Now let's make the let's just fill the electrons in these orbitals according to the electronic configuration. The 2s is having 2 electrons. So the first electron in 2s with a spin of plus 1 by 2, and the second electron in 2s with a spin of minus 1 by 2. Now let's talk about the 2p. The 2p is also having 2 electrons, but we will fill them according to the Hund's rule. So that's first electron in 2px with a spin of plus 1 by 2, and second electron in 2py with a spin of again plus 1 by 2. So first of all, this is the ground state of the carbon. Ground state, electronic configuration of the carbon. Sorry. Now let's come back to the Lewis structure. Here carbon is forming 4 bonds, and I have also told you that when 2 atomic orbitals of different atoms combine or overlap, first of all they must have 1 electron each. But according to the configuration, we are having only 2 orbitals, that's 2px and 2py, which are having 1 electron. So only these 2 orbitals are eligible for overlapping with the atomic orbitals of oxygen. But we need to form the 4 bonds according to Lewis structure. So that means 1 electron from 2s should excite and occupy the 2pz orbital, so that we can have the 4 electrons in 4 different orbitals. So that's why carbon will be able to form 4 covalent bonds. So let's make the excited state. That's 2s with 1 electron. That's 2px, 2py, 2pz, and all are having now 1 electron each. So these 4 atomic orbitals containing 1 electrons will overlap with the atomic orbitals of oxygen containing 1 electron. So they will be the formation of covalent bond, and that covalent bonds will be now 4 in number, because now we got 4 electrons in carbon in different 4 atomic orbitals. So this is called the excited state. This is called excited state of the carbon. Now let's come to the structure again, the Lewis structure. I have I have already told you, in case of CO2 we are having 2 sigma bonds. The carbon is forming 2 sigma bonds, and I have also told you that hybrid orbitals only forms sigma bonds. So that means there are 2 sigma bonds in the structure, so there will be the hybridization which will contain only 2 hybrid orbitals. So that means 1 orbital of 2s will intermix with the 2px orbital of the p subshell. So they will be the intermixing of 1 s orbital plus 1 p orbital. And which p orbital? That's 2px. So now there will be the intermixing of these 2 orbitals. That means this is the hybridization process over here. After hybridization, we will get the 2 hybrid orbitals, because 2 atomic orbitals were mixing. We will get the 2 hybrid orbitals, and the 2 new hybrid orbitals will be the degenerate orbitals, that is orbitals having equal energies. So we got 2 hybrid orbitals. So now what will be the name of the hybrid orbital? It's the combination of 1s and a 1p. So it will be named as sp orbital, and another one also sp orbital having 50% s character and a 50% p character. So here the hybridization is sp. Now what next? We are left with these two unhybrid orbitals. These two will be regarded as unhybrid orbitals, and we also have to keep them aside because they are having 2 electrons, and these are now, that's 2p y, that's 2p z, and these are unhybridized orbitals. So we were having the 4 electrons, so there will be the redistribution of electrons. The first electron in sp, second in sp, the third in 2py, and the fourth in 2pz. So this is the thing up to the carbon. Now let's talk about the oxygen. Now I'm going to talk about the oxygen. What's the valence electronic configuration of oxygen? That will be 2s2, 2p4. Let's make the orbital diagram in the form of box. That's 2s and that's the 2p. Now let's fill the electron. The 2s is having 2 electron, the first electron and the second electron. This one is 2px, the 2py, and the 2pz. And now 2p is having 4 electron, so we will fill them according to the Hund's rule, that first electron, second electron, third electron. Hund's rule states that firstly the degenerate orbitals will get 1 electron each, after that pairing will start. Now here we are left with 1 electron because 2p is having 4 electrons, so the fourth electron will come over here. So that means we are left with 2 unpaired electrons in 2py and a 2pz. That's why oxygen will make only 2 bonds, out of which the one will be sigma and the another will be pi. So now let's come over here. We were having 2 oxygen. Now firstly I'm talking about the oxygen number 1. Here I'm making the 2p orbitals of the oxygen number 1. Let's fill the electrons. Is 1, 2, 3 and the 4, because oxygen was having configuration of 2p4. Now here the first unpaired electron from 2py will form the sigma bond with the sp orbital of the carbon. So that's the sigma bond between the sp orbital of the carbon and the p orbital of the oxygen. So we got the sigma bond that have been formed by overlapping of sp orbital of carbon with the 2py orbital of the oxygen. Now let's talk about the another thing, that's 2pz. This 2pz will now form pi bond. This 2pz will form the pi bond with the 2py electron of the carbon. So that's our pi bond. And the pi bond is formed by the lateral overlapping, the sidewise overlapping of 2pz and the 2pz only. Sorry, let me replace this thing. Let's take it to be 2pz and 2py, because side overlap always occurs between the orbitals which are on the same axis. So we got the pi bond by the sidewise or the lateral overlapping of 2pz of the oxygen number 1 with the 2pz of the carbon. And sigma bond obviously forms by the head-on overlapping of sp hybrid orbital of carbon with the 2py orbital of the oxygen number 1. So that's the thing about the oxygen number 1. Now let's talk about the oxygen number 2. Again I'm drawing the 2p orbital of the oxygen number 2. That's the 2p orbital. Now the 2p is having 4 electrons, the 1, the 2, the 3 and the 4. Now that's now that's 2p z and that's 2p y. Now what's gonna happen? Now the 2pz orbital of oxygen number 2 will have head-on overlapping with the sp orbital of the carbon to form the sigma bond. So we got the another sigma bond that's between the overlapping of sp hybrid orbital of carbon with the 2pz orbital of oxygen number 2, and we are left with the 2py electron. So this 2py will have lateral or sidewise overlapping with the 2py orbital of the carbon, and the formation of pi bond will take place. So I hope you got this hybridization which were involved with the 2 pi bonds. In the oxygen number 1, the 2py orbital is overlapping with the sp orbital of carbon, forming the sigma bond, that's sp and the p, and the 2pz orbital of oxygen number 1 will have sidewise or lateral overlapping with the 2pz orbital of the carbon to form the pi bond. On the other hand, in the case of oxygen number 2, the 2pz orbital of the oxygen number 2 will have the head-on overlap with the sp hybrid orbital of the carbon, forming the sigma bond, that sigma sp and the p, and the 2py orbital of oxygen number 2 will have the sidewise or lateral overlapping with the 2py orbital of the carbon, forming the pi bond. So here we are having the sp hybridization. So here carbon is undergoing sp hybridization. What's the structure of sp hybridization? That's linear. So that means I'm taking carbon over here, first oxygen over here, and the second oxygen over here. Now sp hybrid orbital of carbon is forming sigma bond with the 2py orbital of the oxygen number 1. So that's sigma sp of carbon and the p of oxygen. Now let's come to the second one. The sp orbital of carbon is overlapping with the 2pz orbital of oxygen. So that's again sigma sp and the p. On the other hand, we are also having the pi bond. So the 2pz of the first oxygen is having lateral or side overlap with the 2pz orbital of the carbon, forming the pi bond. So this pi bond is between the 2pz of oxygen and the 2pz of the carbon, and the 2py orbital of oxygen number 2 is forming pi bond, or it's having the sidewise or lateral overlapping with the 2py orbital of the carbon. So that's the pi bond that have been formed by 2py of carbon and the 2py of the oxygen. So that's the exact structure of the carbon dioxide, also with a bond angle of 180 degrees. So I hope you got the point that here the sp orbitals, the hybrid orbitals, are not forming pi bonds, they are just forming sigma bonds. That I have told you earlier also, that hybrid orbitals will never form the pi bonds, they will only form the sigma bonds, and the pi bonds will be formed by unhybridized orbital of the carbon with the orbitals of the oxygen which are on the same axis. I'm repeating it again. here I'm repeating it again, it's an important point, that the 2pz that the 2pz of oxygen is having side overlap with the 2pz of the carbon because they are on the same axis, same parallel axis. On the other hand, the 2py of the second carbon is having side overlap with the second oxygen, the 2py of the second oxygen is having side or the lateral overlap with the 2py of the carbon because they are also on the same parallel axis. So that's all for today. I hope you got the today's topic. And one thing more, here in this case also we were having two endothermic process. They were the promotional energy, that's the excitation of electron. You can also write the excitation energy. I'm writing it plus, it is required, that's why I have written plus. And the hybridization energy, here also the hybridization energy and the promotional energy will get compensated during the formation of both the sigma bonds and the pi bonds. So here I am writing all this process is exothermic, which compensates promotional energy and hybridization energy. So that's all about sp hybridization having two pi bonds in the structure. So I hope you all understood today's lecture. It's a very easy one. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.